Thank you very much for coming back. For this session, we are going to concentrate mostly on GIS, where we talk of the geographical information. On the GIS in front of you, you can see that we've got the geographical information system. Remember, they can give us this concept, and then they say to us, what does it stand for? Then it stands for your geographical information system. Under GIS, pardon me, you've got your components of GIS. Your components of GIS is all the process that has to be followed to accumulate data, where you collect data. After you have collected data, the data must then be manipulated. After it has been manipulated, it can start now to be used in various sectors. GIS can be used in many sectors. You can use GIS in mining, you can use GIS in the military, you can use GIS in any sector as long as it is accommodating the needs of your institution. Under the components of GIS, you've got your software, then you've got your hardware, you've got people, you've got the methods of collecting data, and then you've got the information itself. Now, for you to get the information, it's important that you use the first resource, which is people. Now, these people will gather the data that you want, any information that you want. After they've gathered the very same data, they will now start to store the data using your hardware after it has been saved in your software. From the components of GIS, we move to the analysis of data. It's very important that you define your problem. That's why we say GIS can be used in any format. Then, after you have defined your problem, then you define the criteria. Which steps that are you going to follow to gather the data that we have talked about. Then you build what you call a database, your sets, your data sets, where the whole information will be stored in. From there, you come now to analyzing data. Analyze data, make sure that the whole information is clear for whatever specific reason that you are going to use it for. After you have analyzed the data, now you come to the output. You've got the end result, that this is the information that I've gathered. Now the very same information will bring you now to the decision that you make. Now, you cannot make any decision under GIS if you don't have all the components that you need for your GIS information. Under GIS, we are having very important concepts that you must be familiar with. Amongst them, you've got remote sensing. Then when we define remote sensing, we say this is where you access information without any physical contact with the area of study. An example of remote sensing, it can either be your aircraft or your satellite. Now, under remote sensing, we normally go to our houses, we use a remote. We are not physically in contact with the television, and we gather the very same information. Now, GIS uses satellites so that you can be able, or aircrafts, so that you can be able to get an information from any area. The second concept that I want us to look at is map queries. What is map queries? Map queries is when you ask questions to solve a problem. For example, if you want to open up a coffee shop, it's very important that you ask yourself several questions. Will this coffee shop be within, remember our classes, we've got high income people, low income people, and middle income people. Now your coffee shop has to answer any questions that are asked as to is it on the right location. Then you can also ask a question in terms of a particular route that you want to move from a certain place to another one. If you want to move from Bloemfontein to Bethlehem, then you can use your GPS, your navigators, that can give you the direction. But what is it that you will have entered as an information first? You will have said, I'm moving from Bloemfontein and then I'm going to Bethlehem. Now, you will have asked a question, you have had a query. After asking that question, then you'll use GIS in a form of GPS to give you the direction to a particular place. The third one, you've got buffering. Buffering means what? It means the demarcation of an area of study. Every time under buffering, I'll give you a simple example. Normally when you've got a car accident, the first thing that you do when the police arrive, what do? They buffer the area of study. They will buffer the area so that no one can have an access into it except them. So buffering means your demarcation of the area that you want to study, so that it becomes only those that are allowed to be within that, and that will be your buffering explanation. When you look at the slide before you, you'll find that that area is flooded. This was a question paper for November 2011. The area is flooded with water. And it's important that under the very same area, the people who will be controlling those floods or working with the area, they will buffer the area. They will end up demarcating this area so that no one has an access to the particular area. Then you've got data manipulation. When you manipulate data, what do? We move deeper. We process. This is a process used to organize data for your specific needs. If it's a military section, they will organize data so that it meets their needs in terms of data manipulation. Then you've got resolution. Resolution goes with the degree of detail and clarity of an image. Under resolution, normally this is where we use our cameras, where you zoom in and you zoom out of a particular feature. What do you want? You want a detailed and a clarified image for that particular place or a particular picture that you'll be taking. Then I want to move on to an attribute data. These concepts are very important to put at the back of your mind, because they are part of the whole examination, especially the last part of paper 2, which carries 20 marks. Attribute data, it's a descriptive data, words and numbers together with their own pictures. Then the spatial data is a data that can be specified by referring to a geographical location. I want us to go deeper into these concepts by talking about the thematic layers. Every time when you look around the towns, you'll find that you've got a complete town. This is the real world. But before you had a complete town, GIS has been used to put on layers or thematic layers, where you'll start to find that you've got the raster, which is in a form of pixels, where you have the elevation, your terrain. Then you have the land usage. What was that land used for? Then you've got your parcels. Then you've got your streets that you get there. Then you've got the political divisions or boundaries that it divides. Remember, we've got 9 provinces. Our 9 provinces are also divided in terms of borders. So that is the very same thing. After you've got all these layers, one on top of the other, they are being put or placed on top of one another to give you the final real world. Then we call these the thematic layers that you get within the GIS. Now, these layers can either be in a form of a vector, either in a point or in a line or in a form of a polygon. You can see here, you've got your polygon. Here is another polygon that you get. Here you've got lines that forms what? Streets. But the very same lines, we know they are being described from the vector data, which can either be a point or a line or even in a form of a polygon. Then you've got raster data. Raster data, you get it in a form of pixels or small grid that gives the clarity of an image. The vector data and the raster data, I'll also dwell deeper into it when you move to the next slide. This is just another example of what? Of data layering, where you put all these layers on top of one another to give you the final product under the thematic layers. Another good example is this one under the vector and the raster data. Say a vector data can either be a point, a vector data can either be a line, but immediately you boundary them, then it becomes a polygon. Now, in this instance, they've put their own customers, they've put their own streets, they've put their own parcels, elevation, the land usage, then you've got the final real world under the geographical information system. GIS can also be used under the health department. What do we mean by that? If you've got a way of saying how much people are covered with any disease that you can think of, they will start to say these are high spots where you've got maybe people of TB, then here you've got people of malaria, and then here you've got people of measles. And all of the GIS importance is that it can be used in any sector as long as it can satisfy their needs. Remember, you analyze information so that at the end you can make the final decision to have your product. You've got a vector data, like I said, that I'll dwell deeper into it in a form of points, lines, and polygons. You've got your raster data. Now let's look at the difference. In a vector data, your x and your y axis, you've got your line. All these lines with these points that you get before you, immediately you join them by a line. Remember, there will be first points, then immediately you join them to make one complete line. They will give you a polygon. But the very same information from the vector data, now you move to the raster data, where we say these will now be in a form of grid blocks, pixels, where they will form the same line that you get here, but in this instance it will be in a form of pixels. A polygon that you get in a form of a vector data, you can also get the very same polygon in a form of a raster data. Main difference is that in a raster you work with pixels, you work with grid blocks. In the form of a vector data, you work with points, you work with lines, and when you join them, they give you a polygon. Another clear picture of a vector data is a point. Join points gives you a line. You join lines, it gives you a polygon. In a form of a raster, you've got a pixel in a form of a grid block. They form a line in a form of a grid. Then you've got it also in a form of a polygon. Now I want to move straight to your question papers that we must work with under question 4, which is your GIS. The very first concept that you get in front of you is where we explain what is a spatial data. Now, a spatial data is data that refers that refers to the shape, data that refers to a shape, and the location of a geographical feature. Using your own coordinates. Remember, we are still using a map of Harry-Smith. Then you get the next question that says, state the spatial data allocation for Harry-Smith. Now that's where we are talking about your coordinates. If you look into your map, for you to get your coordinates of Harry-Smith correctly, this is where we move to say we've got 29 degrees, 00 minutes. Then we know that our lines of longitude, they must stretch towards the east. And our line of latitude, they must stretch towards the south. For you to confirm it, if you've got 15 minutes, this will be 16, 17, 18, 19, and then you've got 20. 20 will confirm to say your line of 28 degrees 15 minutes is moving southwards, and the line of 23 degrees is moving eastwards. When they use GIS, one will state that the spatial data allocation for Harry-Smith, which will be 29 degrees 00 minutes south and 28 degrees 15 minutes east. Now, how did they get all these coordinates? I'll give you an example of those coordinates. For example, let's come to our map. Maybe the question says, give the coordinates of a benchmark. Give the coordinates of a benchmark. Benchmark 1629,9 in block C3. In block C3. Now I must get the coordinates. To get these coordinates, I must start first, latitude first. Must move southwards. This will be my line of 15. This will be 15, 16, 17. Now I will have 28 degrees, 17 minutes. Now there's a formula that you must apply to get your seconds. You measure from this point to the benchmark. From here to here with your ruler, it will give you 5. Then you've got 5 millimeters over. Then you measure the whole block. When you measure the whole block, it gives me 37. Then you say over 37. Remember, a block, it's out of 60. Then you go to your calculator. Then you've got 5 divide by 37 multiply by 60. Then you've got 8 seconds south. In total, we have used this formula to get the seconds. In total, you'll have 28 degrees, 17 minutes, 8 seconds south. That is the latitude. Now we must move to the longitude of the very same benchmark. Now we must start from 290012. Then we have 29 degrees 02 minutes. Remember, must use that formula to get the seconds. Then you measure from the beginning of your longitudinal line where it starts to the point. It's giving me 2 millimeters. Then you say 0.2 millimeters over, what is the distance of the whole block? It's 31 millimeters. Then over 31 multiply again by 60. Use the same formula. 2 divide by 31 multiply by 60. You get 2 divide by 31 multiply by 31 multiply by 60. It gives you 0.38, which will mean 0.4 seconds. In total, it will be 29 degrees 02 minutes, and then almost between 1 to 0 seconds direction will be south. Why so small? The margin of it. You can see that when you move from your longitudinal line towards the benchmark, it's just a split of it. That's why you find your seconds being so minimal. But if you wanted to have clarity better on it, remember each block you divide it into 3 sections: 15, 30, 45. Also the longitude, it will be 15, 30, 45. So if you move southwards and you are just here, you have not yet even reached 15. That's why you get 0 to 4. That's why I say 1 to 4 or 1 to 0 seconds, because you have just moved a small margin out of it from that point. And that will be how did they manage to get what we call the coordinates of Harrismith from the map. Then refer to the orthophoto map, which shows a high spatial resolution. Now explain the term spatial resolution. Then resolution will be the clarity of an image to get it more and more clearer for you. This is where you've got a detail and clarity of an image. Remember the concept when I started to show you what you mean by resolution, spatial resolution. So when you define the spatial resolution, that's when we have a detail and clarity of an image. Why can one say that the orthophoto map has a high spatial resolution as compared to a what? To a topographical. If you compare the two, if you take your topographical map, I want to come back to this area, and you take your orthophoto map, why is an orthophoto having more resolution. Why are the pictures more clearer here than you have it over the topographical map? Now let's refer back. A topographical map is 1:50,000. An orthophoto, this is your topographical. It's 1:50,000. Your orthophoto is 1:10,000. Every time we say an 10 into 50 goes 5 times. Now, any picture that you get over a topographical map, an orthophoto map, is enhanced. It is more clearer than a picture that you get over an topographical map. That means your orthophoto map, it's more clearer and detailed than your topographical map. Why? Because your orthophoto map covers only this part. That's why its resolution is more clearer. But a topographical map covers a large area with a scale of 1:50,000. Then we say why an orthophoto has a higher spatial resolution, because an orthophoto map is large. It has a larger scale than a topographical. It's not about numbers. It's not about numbers to say the other one is 50,000, the other one is 10,000. That this one is 10, then this one is 50. Therefore, this one has to be bigger. No. This one is more detailed. It has a larger scale, because pictures, if on a topographical map, we'll give you an example. If on a topographical map you have a building or a polygon, this will be on a topographical. On an orthophoto map, you'll have this building very clear to show that this is an industry that has chimneys, it has an entrance, and it has the main gate this side. So an orthophoto becomes more detailed, more clearer than only what you saw to be a polygon in a form of a building on a topographical map. Then let's go to question number 5. How can GIS assist city planners to determine where a new shopping complex can be built in Harrismith? Now, GIS can help because it can, number one, help with suitable location. This reminds me of another question that it comes to my mind of the past papers. The second part, how can GIS help? It can determine profit by looking at income bracket of people. Income bracket of people. So every time when you use geographical information system, it does not only give you the best, but it gives you the super most location. Why am I saying that? There was a question that asked you that you wanted to open up a hip-hop company. Hip-hop shop, may put it that way. That if you, how can GIS help you with a hip-hop shop? Number one, GIS will look at all the areas in Harrismith in terms of competition. How many shops do you have there? Because GIS must help you to get what? An income of people. Then after it has looked at competition, GIS will go on to say, what is the best location for this shop of hip-hop? The best location. That's where we started to say, for you to locate and make money, you cannot locate in a low-income people, but instead you will move to a high-income people so that they can be able to buy from your store. So it's important that you put this one at the back of your mind. How can GIS assist with a new shopping center in terms of building it? It will help, number one, with a suitable location. Now that location, for it to be suitable, it has to look for a profit. And for you to look at profit, obviously, you have to look at an income. Are those people able to have a buying power? I want to attend to this question because it's coming repeatedly, and it's important that I address some of the questions that are coming. Initially, when I started, I said, let's make sure that we know when you talk of the mean magnetic declination. What is it that we are talking about? I want to answer the question to say, calculate magnetic bearing. You've got the mean magnetic declination, you've got your true bearing. I want to make an example. Calculate mean magnetic declination for 1920. Giving you an example. Now, remember, magnetic bearing, it's a combination of both what? Mean magnetic declination and the true bearing. Now the question says, calculate mean magnetic declination for 1920. Information will be given. The information that will be given will be saying, on the map, mean magnetic declination is 18 degrees 25 minutes west. And the mean annual change will be 5 minutes west. And the whole information will be falling for which year? For 1909. Question says, you must calculate for 1920. But the information is for 1909. Now what did I say? First step is that you must subtract difference in years. Difference in years. Then you say 1920 minus 1909. 1920 minus 1909, I'm left with 11 years. I'm left with 11 years. Now, the second step says the very same difference in years multiply with what? With your mean annual change. With your mean annual change. That will mean 11 years multiply by 5 minutes west. Now, is it 55? 11 multiply by 5 will give me 55 minutes west. Then I must bring down the mean magnetic declination. Then we say the last step we say mean magnetic declination is 18 degrees 25 minutes west. The answer that I've just got is 55 minutes west. When I started, I said there are 3 rules. West and west, you must add. West and west, you add. West and east, you subtract. Answer always to the west. Now, I must add 25 plus 55 gives me 80. Remember, your minutes can never be above 60. Immediately you've got 80, it means you must subtract an hour from this. Now 80, if you take 60 out of it, you are left with 20 minutes waste. Then that 60 that is remaining from here, it must now be added to the hours, then it will give you 19 degrees. If you got me correct, I want to answer this question of magnetic bearing. Now, at the very same point, this is what? Mean magnetic declination. Now, you have 2 points. You've got a point here. Question says, calculate true bearing from spot height 10 to trig beacon 6, height above sea level, let's say it's 1282,1. True bearing from spot height 10 to trig beacon 6. I said under true bearing we also talked about rules. Rule number 1, where the question says from, what do? You make a cross. That's the first rule under true bearing. Second rule under true bearing, you join the 2 areas or points. You join the 2 points. Rule number 3, we said you must rotate clockwise. Let's apply the rules. Rule number 1, make a cross where the question says from. So it says from spot height 10. So here's my spot height 10. Then I'm making a cross. All right. Okay. I've made a cross. Next, after the cross, I must join the 2 points. Then I'm joining the 2 points. It's from here up to there. After I've joined the 2 points, the third step says I must rotate clockwise. So I must move up until I arrived at my point. Then I must look for a protractor. If I put my protractor here, I can see that I've not yet reached my point because I'm circulating clockwise. So already I've got what? I've got 180. You see the readings here. They stand at 180. I've got 180 degrees. Then I must turn it to accommodate my point. Then I must calculate again from 0. I've got 81, 2, 3. I've got 84. Just before 90. I've got 84. Now I must add the 2. 180, that one plus 84. I've got 4. 8 gives me 16. Then I've got 264. Yes, 8, 16. I've got 264 what? Degrees. Then the direction will be 264 degrees. My direction will be southwest. This is what? This is true bearing. I've got 264. I want to confirm something here. 9 by 3 will give me 270. I'm correct. 264. Now, from here up to here, I've got true bearing. Here, I've got the answer for what? For mean magnetic declination. Magnetic bearing, it's a combination of magnetic declination and the true bearing. After calculating it, I've got the answer for magnetic declination. Now here I've got the answer for true bearing. Now I must add the two. I must add the two to get magnetic bearing, which will give me 19 degrees 20 minutes west. Then I must bring down 264 degrees, which is this one. Degrees should come below other degrees. Answer to the west, 20 will come down, 20 minutes, and then I must add now. 264 plus 19 gives me 283 degrees. Now, what will this answer be? This answer for me will now be my magnetic bearing. This will be my magnetic bearing, where I added the true bearing, the mean magnetic declination and the true bearing to give me magnetic bearing, which will be 283 degrees. Let me move straight to another example. Let me take another example so that it can be now easier and simpler. You move from this point to this point. What will this be? True bearing. Here you've got spot height 10. Here you've got spot height 55. I want to make it easy. And my answer here was 19 degrees 20 minutes west. Under true bearing, what do I do? From here to here. From, I make a cross. First step. Second step, I join the 2 points. Third step, I rotate clockwise. Now I have what? My protractor. I put my protractor. I now have 144. Then I've got 144 degrees. What do I do? This is true bearing. This is mean magnetic declination. Now I add the two. Come down 19 degrees 20 minutes west. Now 144 will come under the degrees. Answer to the west. We've got 20 minutes. Add now. 144 plus 19 will give me 163 degrees. This will be my magnetic bearing. This will be my magnetic bearing. All what I want to emphasize while I'm still on bearing, if you get a question that says, just a clean question, calculate magnetic bearing, mean magnetic declination. If you get a question that says calculate the mean magnetic declination without not giving you a year per se, you don't have to panic, because you know that we use what? The current year, which will be 2013. So if you get it without not any year on it, you don't panic, we use the current year. But if they've given you a year, like in this instance for 1920, or a year for 2010 or 2011, then you use that year to subtract your difference in years. But if you are not given any year, you must know that we use the current year. And I hope that one is much now clearer. I said mean magnetic declination given after you have calculated it. True bearing, calculated it. Spot height 55, spot height 10, you got 144. What do you do? The answer for mean magnetic declination and the answer for true bearing, you add the two. They give you what we call the mean magnetic bearing. I hope that one is covered, but because it's coming from time to time, I think I must conclude with it at a later stage if I have time. I want to complete this part of GIS. Now I want to move to the last part of my question. Now I've used my papers here, I cannot see them clearly anymore. You've got your spatial resolution, just like I've said. What is a spatial resolution? This is where you have a detailed degree of information that goes with clarifying the information. The second part of it, why can one say the orthophoto map has a high spatial resolution? I've just said it. It's because your orthophoto map has a larger scale, not number, scale. Even though it's 10,000, but it is larger than the topographical map. And it shows most of the features mostly in detail. Then the last part that I was doing was, how can GIS assist planners for a new shopping complex? What is it that GIS will do? GIS will locate that place on a better area where you will build your own shopping complex. It can also help you to talk about the profit that you'll be making, because it is important as a business person. It can also be used to determine the route. If you want to move from this place to another place, then what will be the route that you can use to get the GIS part. For February, March 2013, I've covered you with GIS, with most of your questions there. Then I want to move to the last part of my presentation, which will be the November 2010 question paper. Please use your resource. There's a resource pack that you get there of Mind the Gap. Use your resource profitably so that you can be able to answer our questions correctly. Let me move to the last part of my presentation with you before I leave. This is my last part with you. Identify a polygon feature and a line feature. Which features are we talking about? You must identify your polygon feature, and you must also identify a what? A line feature in block C2 using your map of Harry Smith. There are many maps around me here, so I must make sure that I come right with it. Let's go to block C2. Block C2, block C2, you've got the detailed information there. Your detailed information there. Now you must identify a line feature, like the question says, and a polygon feature on block C2. You can only be able to identify it if you know that what will be a line and what will be a point. Let's look at C2. When you look around here, you'll find that there's a dam. Now, a dam will represent a what? A polygon. A dam will represent a dam. Come on. A dam will represent a polygon. And then we also have on the very same area a street block. Just a simple part that you get there. It forms a street block. But because it is complete and it shows a polygon, then you'll also have a street block. You'll also have a street block. Then when you move further there in the same block, you'll find that there's a recreational area there, REC. A recreational area, either a golf course that you get there. Then we say the third answer here will be your recreational area. This question is very simple and straightforward. All what it needs you to identify your polygon. Where you've got polygons. It can either be your dam in a form of a polygon. It can be a street block in a form of a polygon. Your street block. If you know what's a polygon, then it can either be your recreational, where you see something like a stadium or a golf course that is also enclosed to give you a recreational area. A recreational area. That will be about the polygon and your line. Now let's go to the line feature. When you look in the same block, you must get a line. A line here can either be a road that you'll get a road, and then a line feature can also be a row of trees. Look at it. You've got trees there that are in a form of a line. Then you say also the trees. My learners, if you look at the attribute data, that's the first part that I've started with. How do you explain the attribute data? So GIS as the last part of your question paper. Please use 2010 paper that you get on your resource pack, 2011 question paper, and also the February-March 2013 question paper on GIS in terms of those concepts. Then what is an attribute data? It is a descriptive data. You describe. Descriptive data. Describe that you get on it. Then 4,2,2, name one. You see, what is an attribute data? It's a descriptive data. Follow-up question. Name one attribute of the N2 in block A2. Let me move now to block A2. Yes, block A2. What is a descriptive data that I'm going to get here in block A2? And then you see you've got your national road there. Then we say a descriptive data that you get on N2, it is a what? It is a national road. Then we move to question 4,3,3. Data integration. Data what? Integration is the combining of different types of data for the purpose of, remember we said GIS want the end result, the end product. Then discuss two types of data that a farmer in block A5. Listen to the question, high order question, application, that a farmer in block A5 will consider before cultivation. For you as a farmer in block A5, I'll move to A5. Before cultivation, what is it that you look for here as a farmer? If you look around there, you won't get anything. But it's a high order question, it's an application. What do you need as a farmer? You need water. What is it that you need as a farmer? You need fertile soil. All those question papers should be used for application purpose. I want you to pause for now for a few seconds and then we take a break, and then we will come back after a few minutes. Thank you very much for coming back. I think it's important that I make follow-up on questions regarding the drawing of a cross-section. That every time when you draw the cross-section, it's important that you look at your contour lines carefully, because that will determine as to how will your slope look like at the end. Before you find that if a question says draw the cross-section, I gave you an example between A and B. First thing that we do, we look at the numbering on our contour lines. Then we take a piece of paper, we place it over between A, which is the starting point, and the second one will be B. Now, every time when we are in contact with the contour line, we mark it. Come in contact with the contour line, I want to mark it with a different color so that you can see it clearer. You've got one, you've got the second one, you've got the third one, the fourth one. It's a repetition of this one. You come across this one and this one and this one. 140 line, we cross it here, then we cross it here, then we cross it here. I'm saying every time when you come in contact with the contour line, we mark it. After we have marked all the contour lines, then we must look at their numbering. This contour line, when you look underneath here, let me put it clearer, it's a contour line of 80. Now I write 80. The second one, it's a contour line. When you follow it up, it's a contour line of 100. Then I write 100. I prefer to write it downwards so that you have enough space. Then after 100, it will be followed by, it's not written. You don't see it here and it's not written, but when you look here, you've got a contour interval of how much? Of 20. So it will be 80, 100, then 120, then 140. But be careful. This 140 line is repeating itself this side. Even if you could look underneath here, it's the same line from here up to here. So it means it will be 140, and again this side you get 140. This one is a line of 120, then you've got 120. Now you've got another new one. Let's look underneath. It's a contour line of how much? Of 100. Then we write 100. Look at it again. It's still 100. Then you check the next one. It's a contour line of how much? This one. It's a contour line of 120. Then you write 120. Then it's repeating on the other side. That will be 120. Be careful. That 141 is not touching anywhere on your line, because it says draw the cross section between A and B. Now there's a straight line that is drawn for you. Then you follow your line straight. Then you move to the next one. You check this contour line. It's a contour line of how much? Of 100. Let's confirm it. This one, it's a contour line of 100. Then the next one, it's a contour line of how much? Let's confirm it. It's a contour line of 80. Then you've got 80. Now, after you've got all your data on your paper. Now you must transfer them on your Y and the X axis. I'm moving a little bit lower. Then me use my ruler to have my Y and X axis ready. Your Y and your X axis. It's okay. After that, you come to your readings, the data that you have just drawn from your initial feature. Then you say, I started here, it was A, then we remark it. Normally this is given in an examination. All what you have to do is to get the information and you place it over the paper. Then this will be, me use a different pen so that it becomes much clearer. Then the second one and the other one, we mark them as it appears on your paper. Then here you've got B. Here you've got B. And here we've got A. Now let me translate them, transfer them to 100, 120, 140, another 140, which is this one. And then you've got 120, and then you've got 100, then you've got another 100, then you've got 120, you've got another 120, then you've got 100, which is this one, you've got 100, then you've got 80. Second step will be, when you look at it, the lowest value will be how much and the highest value will be how much, with a measurement of saying 1 centimeter represents 20 meters. For every centimeter, it represents 20 meters. And we have your ruler. I want to start correctly from 0. Let's check here. From here up to here, it's a centimeter. Second one, third one, fourth one, fifth one, and the last one. 1 centimeter will represent 20 meters. The lowest value on your x-axis is 80, with an interval of how much? An interval of 20, 80, 100, 120, 140, 160, 180. The highest, did I accommodate it? Yes, the highest is 140. I've even moved more than I should have. Doesn't make any problem. Now I must plot it. 80 must go to 80. Got a point. Then 100 must come to 100. 120 should come to 120. 140 should come straight to 140. Then another 140 will come to 140. Then you've got 120. Then you've got 100 line, which is this one. Then you've got another 100 next to the 100 line. Then you've got a 120 line, which will go to 120, and another 120, which will come to 120, and then 100 next to 100. Then the last one will be 80 next to 80. After you have done that, starting from B, you join your lines, join your points. From points, GIS to a line, We'll see if it will give us a polygon. Then it will come back to B. This is how we draw a cross section. This will tell you that we've got the highest lying area, which was a mountain, is this one. There's a low lying area in between, which is this one. Then you've got another mountain. Remember, we did not use that small one. We used this bigger one, which will be from here up to here. And then we joined it towards this. And this is how you draw your cross section. Given between A and B, I said the first step, you put all your contour line readings on it. After that, this is normally given in an examination. You transfer them into your answer book. After you have transferred them, each and every digit should equal the digit that we have on the y-axis with the x-axis, and then you join the points and it will give. This is how it looks from an aerial, from above, and this is a side view. Remember, we talk of an urban profile, the side view of the city, but this one will be the side view of a mountain from the side, and this will be from above. I want to give you a simple example again on the orthophoto map. On the orthophoto map, calculate or draw the cross section between 2 and 3. As you can see it. Now what I do, I place my piece of paper on top of it. Then I must check now the readings. I've got 1,000, you can see, I'm not sure if you can see it clearly. I've got 1,700, 1,695. Remember, the contour interval on an orthophoto map will be 5. On a topographical map, it will be 20. So that example that I gave you was for 20 meters difference. Now here, you've got 1685, 1680, 1770, 1675, 1670, 1666, 1600 with a difference of 5. Now I want to do the same example that I just showed you. There you've got your first point, which will be your 2, and then you've got the last point there, that will be your 3. But very important for me is that where it touches, you've got your contour line that is passing there with its own reading of 1700. Then I'll write 1700. Where it touches, I must mark them. Where it touches, I must mark it, mark it, mark it, mark it where it touches. I must also mark this one, and this one, and the last one. Now I must give the readings. First 1 or 2 we said, remember 2 is where we started, 3 is where we ended, though it still also has a reading. 1700, difference of 5, you are moving up. Then you've got minus 5, you'll have 1695. No, more must be 1705. That's why when you look towards the top here, you've got 1706. So to move from here to here, I have to add because I'm moving uphill. When I go down, you subtract by 5. This one is the same as this one. It will be 1705. Less by 5. If you check it, it's the same contour line that you get here. Then you get your 1700. Less by 5, you get 1700, 1695, and then 1690, 95, 1700. Then you've got 1685, and then 1680, and then 1675. I'm now writing very small, 1675. Then you've got 1670, 70, 75, 80, 85, 90, 95, 1700 plus 1, 1705 is the same as this one. This one is the same as this one, which is your 1700. Now I must go to the x and the y axis. You see, it's very compacted towards the end there. I said this will be given. Normally they give us a dialog box that we have. Then we just have to plot our information when we draw the cross section in there. It's fine. Then I must fit it. Then you have, say, where it touches. Where it touches, you must, this will be very thick. Where it touches, you must highlight it. Then I'm marking them so that they appear exactly. At this time I'll be very clever and draw them easier. This will be your 1700. This will be your 1705. This will be another 1705. And this will be 1700. Now I must use my mind to, when I arrive here, I'll make the first one longer so that it becomes 1695. Becomes 1695. Then the next one is 1690. Then I'll make this one longer, which is 1685. Then this one will be shorter, will be 1680, 80, 85, 90, 95. Then the next one will be a little bit longer, which will be 1675. And then this one will be 1670. And then you have your 3 there. After I've done that, now I must have my difference. For every centimeter, I must move 5 meters. Different from this one of the topographical map where we say 1 centimeter, 20 meters. This one we say 1 centimeter represents 5 meters. And you put on my ruler. I'll put on my ruler and then measure them. For every centimeter, it must now be 5 meters. Then the lowest here, it's 1670. 1670. The highest 1675, 1680, 70, 75, 80, 1685, 1690, 1695, 1700, and then 1705 will be the last one. See how did I forge it there? 1670, 75, 80, 85, 90, 95, 1700, 1705. Then you plot them. 1700 should go straight to 1700. That will be it here on 1700. Then the next one is 1705. Should go up to 1705. Another 1705 should go up to 1705. 1700 should come next to 1700. And then 1695 should come to 1695. 1690 should come lower. And then 1685 should come also here. And then 1680 must come next to 1680. And then 1680, 1690, 1675 should come here. And then 1670 should come here. Then I join my lines. move on with my line shape until I reach this one and this one. That's basically how your map will look like when you look at between 2 and 3. Between 2 and 3, that high-lying area will be shown exactly as like this when you draw it from the map from a side view of it, and that will be the cross section. Now I want to answer another question that says, how do you see if the gradient is steep or if the gradient is gentler? When I started, I said every time when you've got an answer that says 1:25 as an answer in gradient, is it steep or gentle? But what do we mean that? We mean one step vertical and how many times horizontal. From here to here it will be one step vertical. 1 is to how many times towards the horizontal side? 25 times. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25. Now, from here you move towards the end. Your slope become gentle. But if you have an answer that says 1:3 or 1:2 or 1:1, it means you'll have moved to 1 step up and 1 step down. 1:1, 1:2, 1:3. So the lesser your answer, the steeper the gradient. The higher your number, like in this instance where you have 25, the gentler your slope. That will answer the question as to how do you notify it to be steep and how do you notify it to be a gentle slope. I want to finish the last part of my presentation with you by answering the last part of the geographical information system that I was doing with you. Before I got those questions, you say GIS allows us to use what? Thematic layers. Remember the slide that I showed you. I showed you a slide where we talk of the thematic layers. Let me try to get it for you. Where we talk of the thematic layers. That every time for you to have a complete place where you've got a town complete, then you've got your thematic layers, as you can see on your slide. The thematic layers where we say you've got your data source. This one is better. This one will be where you've got your streets, your parcels, your land use, your elevation. When you talk of all these thematic layers, when you combine them, they give you the total real world, which is what that question says, that talks about your thematic layers. GIS allows to use thematic layers on maps. Refer to the topographical map and name 2 layers. How many of them? I must name 2 layers of information that were used in compiling the topographical map for human stop. Now remember the slide that I just showed you. Now here's a map. Before this map was complete, it means it was finished with many layers. For example, when you look at just this area covered by the orthophoto map, you've got streets. You've got your street patterns there. Then besides your street pattern, you have the green part, which will be your vegetation cover. This will be your vegetation cover. Then when you look around here, you've got roads that you get. Your roads can either be your freeway or national roads. But besides that, you also have dams or your rivers that you get there. So for us to have a complete map, we started to have many layers, just like I've showed you. The first layer was street, the second layer was vegetation cover, the other one was road, the other one was rivers, the other ones were buildings that were clustered on top of one another. Ultimately, you have a complete map that you see in front of us. But it started as thematic layers that were placed one on top of the other so that they complete the map. Then we can go to the question to say, name those thematic layers that you get there when you look at the block. The first one will be, you have your infrastructure in a form of railways. Your infrastructure. This infrastructure includes what? Your power lines that we have seen. I'll also show you again. Your power lines. You have the second one, you have your land use. Remember, we talk of the land use, which will be your churches that we mentioned there. Then you have vegetation cover. We have your vegetation cover that you get there. Vegetation in a form of what? In a form of your cultivated lands. So every time when you get a question of the thematic layers, we know that a map to be compiled, it did not start there. It started as small layers that were laid on top of one another, just like I've showed you the slide. And when you combine all of them, they give us nothing but the thematic layers. Let me move to question number 5. The hip hop joint company wants to open a what? A new store in Jeffreys Bay. Suggest 2 ways in which GIS can be used to assist with the location of this hip hop company. Now, remember, if you look at this question and the previous one and you look at different question papers, we always have, how can GIS help you in location of places? The first thing, they have to determine the proximity. How far are you from the area? Proximity. From where you want to have your store, from where you want to have your store to people where you have your residents, your proximity residents. Then you talk of your proximity. Then give us a what? Just like I've said with the first one, you open a store because you want to have an income. So you look at the class that you must locate to, and GIS will do that for you, so that your hip hop store, you are not running at a loss. And then, very important, we'll talk of accessibility. What do we mean by accessibility? Accessibility means what? Easy to reach. Can people reach your area? And then we also determine, no one wants to open a store where there's high crime. You look at your crime level. But when you look at all these answers, it's just that they open our minds when we do more than one question paper. But when you look at them, the answers that you get there are high order questions that test your knowledge of your subject in terms of your application. From here, I want to move to the land use zones. Under the land use zones, I said, firstly, remember you've got the city center, which is the CBD. Now we say the CBD, where is it located? We'll always find it next to a station. You don't have a town where the station is outside the area. CBD will be around the station. Now, characteristics of the CBD. what are the characteristics of the very same CBD? Say one of the characteristics of the CBD is that it has tall buildings. Paper 1 information. The second part of it, you say it is associated with high traffic congestion. High traffic congestion. The third part of it, you find that your CBD, with all its dilapidated buildings that you get around it, you've got more people. Now, all this information, you always consider them when you talk of your land use zone. We move from the land use zone. Now let's move to the rural urban fringe. The rural urban fringe. And how do you define the rural urban fringe? This is where both rural and urban area are intermingled, or where they meet. That every time when you move from the city center, let me give you a sketch here. When you move from the city center and you move to the outskirts, moving away from the city center to the outskirts, you'll find that you've got the outside part of the city, which will be your outskirts. And this is where you get your rural urban fringe. Now, within this rural urban fringe, what are the characteristics also of the rural urban fringe? Characteristics of the rural urban fringe. We say number one, it is on the outskirts. It is associated with more space. Then what are the functions? Very important. What are the functions that you get on the rural urban fringe? You get functions like your symmetries. We get functions like your golf courses. This is part of the information that you must carry to paper 2. You've got functions like your airports, and then you've got functions like your silos. Remember the silos where we store food. And for each and every one of it, there's a reason why do you get. You can also mention your industries. Your industries that you get on the rural urban fringe. You put them on the outskirts because of what? Because of pollution. Silos, remember they store food, they need heavy transport. Then we say they must always be near your main roads. Near your main roads. Then airports, because they need space. But worst of all is that there's a lot of pollution that you get. In this instance, we talk noise pollution. A golf course, why do you get it on the outskirts? Equal enough, it needs space, but it can be dangerous to people to play golf within the CBD. Symmetries, why do you get? Then because the area should always be peaceful and for space, since it expands on day-to-day basis. Sometimes when you look at other maps, I'm not sure about Harry Smith, let me check it. Harry Smith, when you look on the outskirts here, you can see, I'm not sure if you can clue deeper. You've got crosses that shows you those are symmetries. You find them on the outskirts because they'll need space. But in some instances, you find that through urban sprawl, when the town started to expand and become bigger, you find some of the symmetries within the residential areas. It does not mean that then symmetries can only be located on your outskirts. Information that must be carried to paper 2 on land use zone. I want to move to the second land use zone, which is your zone of decay. Your zone of decay. Now remember where you get. You've got your city center, you've got the rural urban fringe, but an edge here, just on an edge of the CBD, you've got what you call your zone of decay. Zone of decay, or in another book they call it your transitional zone. This is your transitional zone. Then what do you do with that? Let's talk about the characteristics that you get. When you define it, this is the area outside the what? The CBD. You also get to say it is where the CBD expands into. Immediately when the CBD expands, it expands over your transitional zone. What are the characteristics in the transitional zone? Number one, it is associated with more crime. The transitional zone. What is the state of their buildings? They've got old, dilapidated buildings. Then we say the very same area has mixed races. Mixed races that you get within the area. Automatically it starts to tell you that the area is very dirty. In some instances you'll get a case study, especially on paper 1, on the the zone of decay and how does it relate to that. But this information has to be carried to paper 2 so that if they talk of the land use zone, you can be able to locate easy what is it that we are talking about in terms of the information that we have gathered from the first paper. Then another land use zone that we have, we talk of your industries. Then characteristics of your own industries is that they are found on the outskirts. Why? Why on the outskirts? Because they make a lot of pollution. Further than that, the very same industries, they are associated with space. They need a lot of space. So that's why we found them always on the outskirts. From your city center to the transitional zone to the rural urban fringe, and then you move to your zone of decay, then you move to your industries that you also get. And very important, there must be reasons why you say this one is found on the outskirts or the location where you get it, especially with the concept of the rural urban fringe. I want to move further from the rural urban fringe. Now let's move to the issue of landforms. Remember, under landforms we've got 3 types. Landforms associated with what? With horizontal strata. Landforms associated with horizontal strata. We've got the landforms associated with inclined strata. And then we've got landforms associated with massive igneous rocks. Normally these two, inclined and massive igneous rocks, we don't get them easy on paper 2, but they normally focus on the landforms associated with horizontal strata. If you look at the previous session that I was talking about, I started to identify features on a map as to, is it a conical hill, is it a mesa, Is it a butte or it's becoming a plateau? So the landforms associated with horizontal strata, they're very important. You look at your map, you look at your features, look at block C9, Queen's Hill there. When you look around, you'll find that your sizes will definitely differ. And when you compare that one with the other one in block H13, you'll find that it becomes a little bit smaller. Then when you compare that one with the one that you get, let me look for another one that I talked about, so that we don't jump here and there. We talked of this one that you get in block E and F 4 and 5. Compare the three, the size of this one, the size of this one, and the size of the last one, which is your conical hill. So the landforms associated with horizontal strata are equally very important when it comes to your practical paper that will have a tried to exhaust. I want to conclude here by giving you a nutshell or a brief overview of what we've tried to cover, so that we get ready for the 22nd when we write the paper 2. Every time when you come for paper 2, take note of the following. Make sure that your street patterns are ready. Then we said within the street pattern, we talked of the grid, we talked of the radial, we also talked of the grid, the radial, and the irregular pattern. Make sure that you are ready. Then also make sure that when you talk of your drainage patterns, your drainage patterns should also be fully prepared in terms of, can you identify a dendritic pattern on a map? Can you go on to identify a trellis pattern on a map? Can you go on to identify your rectangular pattern on a map, as I showed you on another map of Harry Smith, where we say a rectangular pattern can be indicated where the mainstream starts to bend at a right angle. Then you can get your rectangular pattern. Then after you have exhausted your street patterns, your drainage pattern, you come to the land use zone. I've just done your land use zones with you. Make sure that you understand the characteristics of each and every land use zone that you are talking about. We also touched on your river profile. We said your river profile can either be your longitudinal profile from the upper course towards the middle course with the lower course. And we said that the upper course, middle course, and the lower course. If you are given a map and they say which course would you classify block B5 with, what features do you look at? Let your river meander, let your river be braided, let you have your meshes and flay. Meshes and flay, it's where we say it's a flat surface where water is trapped, like in block 15 here. You can see that you've got your meshes and flay. And this automatically will tell you that you are in the lower course, because if it was in a high-lying area, water will not have been easily trapped here. Then you've got your cut-offs, both of them, which is either your Oxbow Lake, or your meander scar. Your cutoffs should speak to you if there's any when you look at your map where it has been subdivided and further been subdivided to give you a cutoff that you will recognize easy on that map. For example, when you look at this block, you'll find that block D2, you'll find that the original river flowed towards this side, but this part has now been cut off from the original part. This will be a lower cost. Why lower cost? It's because your river is meandering and the area has been cut off, but worse, you've got your cultivated lands that you can start to say and talk about. I want to conclude by saying it's been good to have time with you, but when you recap, you have a multiple choice question which is 20 marks. Please go through it and make sure that you don't rush it. It's a 1.5 hour. Take all the duration of the paper. Don't waste any time. You get a question that says a scale of an orthophoto map is how many times than the topographical. Then we said an orthophoto is 10,000, a topographical is 50,000. So 10 into 50, 10 into 50 goes 5 times. But be careful. It says 5 times smaller or 5 times larger. Then the correct answer will say your orthophoto is 5 times larger than the topographical map because it has a clear detail, the resolution that we talked about under GIS. Determine the magnetic bearing. Magnetic bearing, combination of what? Combination of the mean magnetic declination and your true bearing. That's why when you look at this example, they've got already your bearing which is between 189 and 190, and then they've got their magnetic declination which is 26 degrees 50 minutes. But very important, what did they do? They added the 2 to say 26 degrees 50 minutes west and 189 degrees. It's worrying me because I've got many questions around this. You've got 50 minutes, you bring it down. 9 plus 6, it will give you 15. And then you carry 1. This 8 plus 2 is 10 plus 1 is 11. Then you've got 215. 189 plus 26, 215 degrees. This is what? Magnetic bearing. And listen to the question. Determine the magnetic bearing. They are just giving you a trick beacon, and they've also given you what? A spot height. For which year? For 2010. Now you have to work with 2010, and then you work with your map information that you get on your map for 2010, where you'll start to say let it subtract 2001, and then you are left with your 9 years, and then after that 9 years you multiply it. This is only 5 marks, but I want you to have your story correct on that one. Draw a freehand. Draw a freehand what? Cross section. Remember, we have just done the cross section. Then if you draw a freehand, I want to show you a simple example of a freehand. If you have to draw a freehand from this point to this point, what does it mean? Because you've got cultivated land here, it will be a flat surface. And then you have a river, it will start to dip. And you also have another flat surface, it will start to be flat. It's a freehand. You don't have to look per se in terms of where you have all your contour lines and the measurements. It's a freehand. You look at your terrain, your slope. So it has to be flat. It's a river, it has to dip. And if it was opposite, and then you have a mountain, and then you are going to have a flat surface, then a mountain, then the other surface. So if you have to draw a freehand from A to B, if you've got a mountain in between, you'll definitely have a straight line. Then you've got a mountain, it's a high-lying area. Then you've got the other side is cultivated land. It will be a flat surface. That's why when you look at this one, they only wanted a freehand cross-section between the 2 points. You've got a flat surface, low-lying area, cultivated lands. Take note, what obstacle do you come across there? If you are coming across a river, then you have to dip. If you're coming across a mountain, it has to take a higher lying area. Then you've got the opposite of this river. Gradient, we have covered it. Area, we have covered it. Mostly we have done the better part of your paper. I want to be very sure that you are going to get the marks that you wanted for. Look at an example of a land use zone. Look what they've done. They've given you a street pattern. After giving you a street pattern, they gave you a flow of traffic. But you have to compare between two areas, at Humansdorp and at Wave Crest. Let's look at the two. You've got Wave Crest, it's here. And then you've got Humansdorp, it's here. What did we say about the grid pattern? Remember, every time where you see a grid pattern, you see an old town. A grid pattern is associated with an old town. Now, if you have to compare the flow of traffic, just like we said, in a street pattern at Wave Crest is here. Which street pattern do you have? It's an irregular pattern. That's why we say you've got an irregular pattern. But look at Humansdorp. Humansdorp is here. What street pattern do you get here? You've got a grid pattern. Second question will say, look the two or compare the two in terms of flow of traffic. If you've got a grid pattern, like we said, the traffic will be very congested. But in a planned irregular pattern, like at Wave Crest, it's interesting. Yes, you can get lost, but you've got less traffic jam. But in a grid block, you've got more traffic jam. What is this question telling us? That we cannot come with the two without not concluding well about them. I want to thank you from the bottom of my heart and wish you the best for your paper on the 22nd. Make us proud. We all love you. Bye-bye.